So let's get this back up. Boom. All right. So everybody understands that's what we're working with these, with the tree. Okay. So basically, if I take 360 and I divide by 32, everybody understands where the 32 comes from. The number of sides times 2. All right. So if I go to my calculator, do 360 divided by 32, I get 11.25. So that angle is 11 1/4 or 11.25. And then this one is, if I do my math correct, 78 3/4. Everybody okay with that? Now, this is what we mean by the question we asked you, and make sure if you didn't do it last night, I realized in this class I didn't put a due date on it. Got to go back and answer this question for the quiz review to get the 10 points. Some of you didn't do it, and I looked, and there wasn't a due date. I understand. All right, when we ask you when to use a ratio, this is what we mean by a ratio. If they give you the radius, you got to get 2 things. You got to get the apothem, and you got to get that segment, correct? All right, well, the radius is the hypotenuse for 12. Make sense? So the 2 ratios you're going to use, okay, sine 78 3/4 equals A over 12. Feel free to use 0.75, by the way, because it's an exact decimal. And cosine 78 3/4 equals X over 12. Give me half a second, okay? Or you can use sine of 11 1/4 equals X over 12. Or cosine of 11 1/4 equals A over 12. So you can use either one. What's up? I just subtracted from 90. That's 90 degrees. So the angles of the triangle have to add up to 180. All right, so that's what it's going to say for show work. So on the quiz, it's going to say show the ratios. So with 10.3, when we ask the question, when do you use ratios when you're doing what? Rhymes with trigonometry. Trigonometry. All right, so that's what I was looking for with that question last night. Sure.
Well, are we going to have to show like all the possible ones?
No, you just have to show what you use. So basically what I would say is either this pair, most likely, if you're using the same angle, you know what I'm saying? So most people are going to use the same angle. So I would look for that pair, or I would look for that pair. Now if you mix and match, like if you did this one with that one, yeah, you're fine. But I would look for 2 of them. I would need enough to see how you found your apothem and how you found your side line. Now, obviously, X is only what fraction of the side line? Half. So you got to take that number and multiply by what? 2. I don't need to see that. So it'll literally say show your work and there'll be lines. I just need that part. So you don't have to put the 2 out there or anything like that. All right? Okay, so now when I do 12 sine, so I don't need to see the multiplication or anything like that. If you want to do, give me half a second. If you just want to do that multiplication, so 12 sine 78.75. All right, so this ends up being 11.77. And when I do 12 cosine 78.75, I get 2.34. And then to do the area, I multiply by 2. So the final part will be show what you plugged in, 1/2. How many sides in a 16 gone? 16. The apothem is the 11.77, and the side length would be 4.68. All right, so that's what we need to see for work tomorrow. Mr. McDonald, what's up? How many questions are there? I think 11. But like the last, and you'll see, we'll talk about it, the last the last question is only worth like 3 points, and then one part of the 10th question is only worth 1 point. I think it's 60. I don't know. I gotta look. I'll look. Because I put the point value for each question on the quiz. All right. So that's what we want to see for work. All right. We're doing that. Good? Everybody good with that? Cameron, you good since you asked about this? Okay, no problem. All right, now the other part of that question, when you use it for similar figures, okay, when you use it for similar figures, all right. All right, so let's look at something like number 8 on the second page. All right, let's look at number 8 on the second page, where it says the areas of two similar octagons are 72 and 128. Find their scale factor. All right, so what I would expect to see within a problem is 72 over 128. What do we got to do with that? We got to reduce. Enzo, what's up? Okay.
So when you're doing trigonometry,
Right.
you're always running which one is running after the other.
It'll say in the problem where to round to. So it says right on the quiz where to round to for each one. The vast majority of it says hundreds. I think there's one problem where it says round to tens. Okay, except for the word problem involving money, and you just round to the nearest cent. Right? All right. So when it says simplified ratio, what does that mean you have to do? You got to reduce, right? So this reduces down to 36 over 64. Everybody good with that? Are they both perfect squares? Yeah, so could you do the square root at that point? Yep, what's square root of 36? 6. What's square root of 64? Can that be reduced? 6 over 8 reduces down to 3/4. Got me? Or you could have reduced 72 over 128 to 9 over 16. And then that would have brought you directly to 3/4. It's not going to affect it. All right? Okay. On the front side, all right, on the front side, something like number 3, where it says the pentagons at right are similar. The area of the smaller pentagon is 30 meters squared. What is the area of the larger pentagon? Okay. So now we're working forward. They're giving us scale factor. What are the two side lengths in number 3? 4 and what? 10. That reduces down to what? 2 over 5. All right. Then we have to do what with that? Square it. And that becomes 4 over 25 equals, they say the area of the smaller pentagon is how much? 30. And then that's the only thing I would need to see for work. I don't need to see all this. You got me? If you want to show me that, you can. But this is all I need to see for work, is your proportion. Because that way, if you set up your proportion right and do your math wrong, will you get credit for doing your proportion? Yes. If you set up your proportion wrong but cross multiply right, will you get credit for doing that? Yes. You understand? So that's why you're showing that. And then 750 divided by 4 is 187.5. All right, 187.5 meters squared. All right, so that's what was the basis of that question, so you understand what we mean. So you're using your proportions with similar figures, setting it up. Again, if you want to show me the reduction of 4/10 over 2/5 and then squaring that, that's fine, but I only need to see the proportion you finally use. All right. All right. And for those of you at home, there's one question where it's just a big essay box, show work. But again, that's the last problem. It's only worth 3 points, so you show as much work as possible for that. All right. So So let's. There's the last one. All right. So to answer some of the other questions that came along as we were going through it. Log in. All right. All right. A little slow today there, internet. A little slow. Entire library, yes. I would like to look at all my tests. There we go. Authored by me. How come 7, 8, 9? You get 3 square meals a day. Like, all right. So the quiz tomorrow to answer some of these questions. Detail. There are 11 questions. There's 11 questions. All right. There is six questions dealing with regular polygons and 5 questions dealing with, well, hold on. That is, okay. You guys are going to have 10. The people in class are going to have 10. People at home, it's 11 because I had to break down 2 questions in it. All right. So it's one where you have to identify the similarity. So that'll be the difference. So you have 1 question worth 8 points total. That the people at home will have 2 questions worth 4 points total. It's the same question. I just had to break it up. So to answer your question, how many? There's actually 10. Okay. They range in value from 5 points to 8 points. So there isn't one that's extremely more pointful, for lack of a better word, than anything else. And basically, if you look at your review, all right, it gives you an idea of what to expect. Like, for example, all right, if we look at the regular polygon side for this, one of your questions is identical to this, where you got to find the angle measure. All right. You have different levels of regular polygons. So you have one question that they give you the apothem and the side line. So you just have to plug it in. One question where you got to use trig once. One question where you got to use trig multiple times. One question where you got to work backwards. All right, what's up?
Yesterday you set up, you recommend writing on a piece of paper the measure angles.
Yep.
Shape. Up to half, like how many sides do we have?
I'd have those in my back pocket. All right, so pentagon, hexagon, heptagon. This is the only one. Make sure you have the fractions correct. All right. The other ones, it all comes out to a nice number, whether it's an integer or a decimal. You know what I'm saying? So like 360 is like 22.5 and 67.5. All right. Things like that. All these come out to be nice numbers rather than this one. All right, so that would be the only one if I was gonna really, if it was gonna be fractions, it would be like that. So if you have that covered, you should be good. All right. And again, what I did is I looked at your 2 homeworks and I just took the problems right from there. So all the problems have been in your homework. So if you study your homework and you got all that covered, you're good to go. All right. Math lab is open. Miss Adams will be down there. I'm sure if you bring your quiz review, all right, she'll be able to help you. So let's talk about an assignment you'll be working on in the upcoming days. And isn't that bad? Sets us up for Circlades, which we will start on Thursday. Friday, you'll get your quarterly review. Monday, we'll go over the first half. Tuesday, we'll go over the second half. And then Wednesday, you'll take the quarterly. That will be over.
The quarterly,
It's the whole year. That's you. Yes, you. So it's the whole year. That's why we're going to give you that comprehensive. Then you should be good to go. The quarterly is designed to help you. So you should have no problem. Compared to like our regular quizzes and stuff, the quarterly should be a walk-in. Just letting you know.
What are we also gonna be looking at?
That I gotta talk to my boss. That I gotta talk to my boss. You're welcome. If it's up to me, yes, Nora, it is. If it's up to me, yes, it is. But I have to make sure that's okay. Okay. Because I am scared of that. Everybody got one? All right, so this needs to be submitted in Google Classroom by Sunday night at midnight. It's the only homework you have over the upcoming days. Anything you get next week will be due after the quarterly. All right. Dealing with circles. Okay, so here's the idea. All right, so going over some vocab. An inscribed polygon is one whose vertices are located on the circle. Ladies and gentlemen, we haven't really talked about it because of our abbreviated material. It's inside the circle. All right. The inside circle. A circumscribed polygon is one in which each side is tangent to the circle. Now, we will go over tangent lines in chapter 12 when we're done with area and volume. However, this is what a tangent line is. If you draw a circle, tangent line hits it at exactly 1 point. All right, that's a tangent line. All right, what you need to know for this investigation, a circumscribed polygon is outside the circle. All right. All right. So looking at each diagram, do you understand which one is which? The smaller one is the inscribed, the larger one is the circumscribed. Good with that? Okay. So basically what you need to do is find the diameter of each circle. The easiest way to do that, ladies and gentlemen, we have given you the center. So each of those points is the center of the circle. All right. Simply draw a line segment anywhere you want that goes through the center. So it can be anywhere. So line it up with your circle, line it up with your point, and then measure. That's all you're doing. So that's your diameter. Everybody good with that? Diameter is a chord that goes through the center. Then what you're going to do is find the perimeter of the inscribed polygon. All right? All the polygons are regular. So you have to find the length of what? One side. And multiply by what? The number of sides. I would use centimeters. So you don't have to worry about fractions. You want to use fraction, you want to use inches, go ahead. But I would use centimeters. So all you're going to do is measure a segment, all right, with a ruler, and then multiply by the number of sides. You're going to do it for the inscribed one, and then you're going to do it for the outside one. So there we go. Good? So you're going to do that for each one. There's a table in the back for you to enter all these in. All right, there's a table in the back. If you want to include units. You don't necessarily have to. All right, I'm assuming, though, you're using the same unit. So if you use centimeters for one, use centimeters for the whole thing. As long as you use the same unit, it shouldn't be a problem. So if I'm doing this, all right, so if I'm looking at this one, that to me is a good 2.5 centimeters. You know what I'm saying? I would go the nearest millimeter. If you have a ruler that goes past that and you want to go past that, go ahead. The more precise, the better it'll be for you. But if you go to the nearest millimeter, it should be fine. All right, now, in the early stages, it's pretty easy to see the difference. The one thing is, make sure as you get more and more, realize it's harder and harder. All right, but it isn't a big deal. You should still be able to do a diameter. All right, you should still be able to do a side length. All right, you should still be able to do a side length. All right, that's all you're doing. Okay, everybody good with what you're doing? All right, now, here's what happens, and I want to make sure we understand the column. Column 1 is just the figure. Column 2 is your diameter. Column 3 is the perimeter of the inside one. Column 4 is the perimeter of the outside one. Now this is, oops, hold on. There we go. All right. Yeah. Sorry about that, people at home. So this is basically what we filled in so far. All right. So I want to go through this. All right. This is the most important part. All right. Those lines in column 5 and 6 are division zones. Okay. So you're going to divide. All right. Column 5 says column 3 divided by diameter. So what you're going to do is take the perimeter of the inside one and divide by the diameter. All right, you can do column 3 divided by column 2. Column 6, you're doing the same thing, but you're using column 4, so you're using the bigger polygon. Again, you're dividing by the diameter. That's all you're doing. All right, so I want to make sure we understand the formatting. Good? So this means divide column 3 by your diameter. This means divide column 4 by your diameter. And then column 7 says average of columns 5 and 6. From using midpoint and everything else this year, how do we find the average of two numbers? Add them up and divide by 2. Good? You're going to add them up and divide by 2. All right. So that's what we got. Okay? Everybody good with how you're putting in your data? Now you're coming down here. Graph your data below. Number of sides, column 7. All right? So basically, you're going to take each of your figures. Now you're not starting at 1, right? What are you starting at? The triangle, which is what? 3. You got me? So you're not starting at 1. You're starting at 3, and you're just going to graph it. So whatever the number of sides was, and then the y coordinate is whatever you get for column 7. All right. Now, number 2, is your data linear? Explain. If you don't remember what linear data is, you just look it up. What does it mean for things to be linear? What is the first 4 letters of linear? Line. That should be enough to figure it out for you. Explain. What that means is look at your data. I'm not telling you it's yes. I'm not telling you it's no. It depends upon your data. Some of you, it might be yes. Some of you, it might be no, and that's okay. Got it? It depends upon the data you have. All right? And you shouldn't all have the same data. All right? You shouldn't all have the same data. You should all have different data depending upon where you're around and what you measure. But again, that may happen. All right? As the number of sides increases, what does your column 7 value approach? All right, and this is what I mean by that. All right? I'm going to give you a function that you're going to deal with next year, rational functions. All right? So we're going to do, let's say, y equals, please work. Come on, work for me, please. Oh, come on, no. No. Hold on. I'm gonna have to graph by hand, no big deal. All right. So next year, you're gonna deal with rational functions in Algebra 2. This just gives you an example of approaching. If you didn't do it last year, it's okay. So let's say you have y equals 5 over x. All right. So let's say you have y equals 5 over x. And you had to graph some points. When x is 1, what would y be equal to? 5 divided by 1, which is what? 5, good. When x is 2, what's 5 divided by 2? 5 over 2 or what? 2.5. If x was 5, what's 5 divided by 5? 1. So is it increasing or decreasing? Decreasing. It's not linear though, right? You get me on that? Because if we did 1 to 2, and if we did 3, that would be 1.7 approximately. It's not linear. All right? If I did 10, 5 divided by 10, all right, is 0.5. 5 divided by 100 is 0.05. If I graphed it, all right, if I graphed it, those points, all right, it would look like that. Where it would keep decreasing, but will it ever hit 0? Will your graph ever hit 0? Won't. Because what number can we not divide by? 0. So as this number gets bigger and bigger, 5 over x gets what? Smaller and smaller. Now what does it approach? It approaches what? 0, but it never quite hits it. You got me? So that's what I mean by that in this exercise. What does your column 7 value approach? So if you do this awesomely, and I do mean awesomely, and if you don't, it's okay. Your answers are based upon your data. If you do this awesomely, for lack of a better word, it'll get closer and closer to a particular number. A number we're going to use over the next week or so very frequently. But if it doesn't, it's okay. All right? You're using a ruler that isn't the most precise measurement, and you're doing the best you can. So it's just to get you an idea where it comes from. Right? Good? Okay, so that's due Sunday. You should be able to measure, you should be able to do all that. If you have any questions about it over the next couple of days, feel free to ask. All you're doing is creating a line anywhere you want. So see how I put my line there? You can put your line here if you want. You'll get the same measurement anywhere you want. So all you're doing is making sure you got a segment that goes through your center and hits 2 sides of the circle. So that's all you got to do, and it can be anywhere. You got an infinite number of ones. All right, those of you at home, if you're good, I'm good. Have yourself a fantastic day. Good luck on the quiz tomorrow. Don't forget to log in Edulastic. Your quiz will be in Edulastic. You guys will be taking it in paper. Close that out. Close this out.